Well, we've come to the end of Unit D, which is Trigonometric Identities. And the purpose of this unit was just to get you familiar with those trig identities so that you can simplify different things and just so that you know what they are. So I'm going to go through these, the review for the test right now. Derive an identity for sine theta in terms of cotangent and cosine. It's the very first thing that you're asked to do. They're saying derive an identity for sine theta. So that's what you're going to be solving for. First step is to look at your trig identities and see which one relates sine, cosine, and cotangent. Well, that is this. Cotangent theta equals cosine over sine. Has all three. Then what you have to do is solve for sine. So we're going to multiply both sides by sine. Now remember, the shortcut way is that the cotangent and the sine just swap position. But if we're doing it the long way, if I multiply both sides by sine, I get sine theta times cotangent theta equals cosine. Then to get sine by itself, I divide both sides by cotangent. Bada boom, bada bing, this would be my final answer. Sine theta equals cosine over cotangent. Deriving the identity for sine, that's the one that gets solved for. Okay, same thing here, Pythagorean identities. So you have to look and see which Pythagorean identity relates secant and tangent. Well, that's going to be, oops, that one's twirly twirl. That one's going to be secant squared equals tangent squared plus 1. So all you have to do is take the square root of both sides. So secant theta would be plus or minus square root of tangent squared theta plus 1. Just leave it like that. You can't take the square root of either the tangent or the 1. Cosecant in terms of cosine is a little trickier. If I start with this one, which is sine squared plus cosine squared equals 1, I'm keeping in mind that cosecant and sine are reciprocals. Now you can go ahead and replace sine squared with cosecant if you want, but I'm going to go ahead and solve for sine squared. So I get sine squared equals 1 minus cosine squared, and then I'm going to take the square root of both sides, square root of the left and plus or minus square root of the right hand side. I end up with sine theta equals plus or minus square root 1 minus cosine squared theta. And then I'm going to replace sine theta with cosecant. But it didn't ask us to find 1 over cosecant, it wants cosecant. So what you do is you just flip both of those. So you'd have cosecant theta equals 1 over plus or minus square root 1 minus cosine squared. And you're done. Derive an identity for each of these. These are, when you see the theta minus pi over 2 or pi over 2 minus theta, right away you should be thinking cofunctions. All the cofunctions are written in terms of sine and cosine. Cotangent is cosine over sine, and it's usually cosine of x over sine of x. However, in this case, we have this big old angle looking thing, ugly, ugly, ugly. And so we're going to write cosine of that whole thing over sine of this whole thing. It's at this point we look at our cofunctions and we say cosine of theta minus pi over 2 is equivalent to, wait for it, sine theta. Likewise, sine theta minus pi over 2 is equivalent to negative cosine theta. So now we have sine theta over cosine theta, which is just the opposite of tangent of theta. So cotangent of theta minus pi over 2 is equivalent to negative tangent. Follow the same pattern for number 5. Pi over 2 minus theta. We know cosecant is 1 over sine. So this becomes 1 over sine of pi over 2 minus theta. Then we look at our cofunctions to see what that is. And I believe that is just plain old cosine. So 1 over cosine, this becomes sine of this is equivalent to this. And again, look at your cofunctions. Once you do that, you end up with secant theta because 1 over cosine is secant theta. So that is simplified to its lowest denominator. Okay, these are easy because these all you're going to do is graph and match the graph. So when you put in sine of theta minus pi, put that in your calculator, and you'll get this graph right here. That's between negative 2 pi and 2 pi. And you have to say, is that sine x, cosine x, negative sine x, or negative cosine x? You just have to know what those look like. So this is, it is the opposite of sine x, or opposite of sine theta. If I do sine of pi minus theta, this is the graph that will come out of my calculator. And that is the same as just plain old sine. So this is sine theta. Cosine of theta minus pi, if I do this one on my calculator, notice It's the upside down of the cosine graph. So that's just negative cosine theta. That's all there is to it. You put those in your graphing calculator and see which one it maps to, that it's the same as. Alright, multiply and simplify. This is kind of blast from your past with your algebra. But if you notice, these are a difference of squares, so we would end up with tangent squared minus cotangent squared. That's all there is that we can do to it. The next one, I would go ahead and make secant of x 1 over cos x, cosecant of x 1 over sine x, and then FOIL it out. I notice some people are not foiling. First times the first, so you'd have sine of x over cosine of x. Then I take the outer, sine x times 1 over sine x would be a 1. Cosine of x times 1 over cosine of x is going to be a 1. And then cosine of x times 1 over sine x gives me cosine x over sine x. When I simplify this out, I get a 2 here, and I'd have tangent of x plus 2 plus cotangent of x. And that's all I can do for that one. Remember the middle child on number 11. You do 1 plus cotex times 1 plus cotex. So when you simplify that down, you get 1 plus 2 cotex plus cotangent squared x. 1 plus cotangent of x is the same as cosecant of x, so that guy can be replaced. Factor and simplify. So looking at number 12, I notice I have a cosecant in both terms. So this would just be cosecant of x times sex minus cosecant of x. So that's all you can do with that one. This is a difference of squares, a plus b, a minus b, so it's going to be tan e plus cot times tan e minus cot. Looking at number 14, you may want to pretend like tangent of x is just a variable like a. So a to the fourth minus 2a squared minus 3, we should know how to factor that one. That's going to be a squared times a squared. So tangent squared x plus 1, tangent squared x minus 3 when you factor it out. Remember that the 1 and the 3 have to multiply to give me a minus 3. Tan x plus 1, tangent squared x plus 1 can be replaced by something. It can be replaced by secant of x. So this would be my final answer for number 14. Secant squared of x times the quantity tangent squared of x minus 3. Alright, this one, everybody wants to slash and burn before they factor, but factor first. So the top is a difference of squares. So you'd have sine squared plus 1, sine squared minus 1 when you factor that guy, and then this guy is going to be sine theta plus 1 on the bottom. Now I can slash and burn to leave just sine theta minus 1. So those get slashed and burned. I end up with sine theta minus 1. Bada boom, bada bing, done. Solve for the indicated trig expression. These are nice because if you know how to factor and you can do quadratic formula, you can do these very simply. So if I think of secant squared theta as like an a squared and that, I can do this. I know how to do this. So add 10 to both sides and then factor it, because 5 times 2 is 10 and 5 plus 2 is 7. So we'll just make this secant theta minus 2, secant theta minus 5 equals 0. Set each factor equal to 0 and you'll get 2 and 5. Cosine. When I solve for sine or cosine, keep in mind it has to be between -1 and 1 for my answers. So if I add 5, I get 6 times 5 is 30. 2 factors of 30 that give me 17 are 15 and 2. So the inner and the outer terms have to be 15 and 2. So when I simplify, when I factor, notice I have 3 times the 5 and the 1 times the 2. So 3 cosine of x plus 1, 2 cosine of x plus 5. If you do not know how to factor, you can use quadratic formula. However, be very, very careful with your signs and everything. So if I set each of these equal to 0 and solve, I get cosine of x equals -1/3 and cosine of x equals -5/2. So I cannot have the -5/2. The reason that one gets thrown out is because cosine is between -1 and 1, and this is -2.5. So that answer gets eliminated, and my only answer is cosine of x equals -1/3. Okay, there you go. That's it. That's what you need. So -1/3 is my only answer. All right, next one, cosecant. Now cosecant cannot be between -1 and 1, so let's see what we get here. If I factor this, 5 minus 2 is 3, and 5 times the negative 2 is negative 10. Set each one equal to 0, you get negative 5 and 2. Everything's copacetic with that. Cotangent of x, if I factor it, cotex plus 10, cotex minus 1. Set each equal to 0, you get these two, which is fine. Cotangent and tangent can be anything. And last but not least, oh yeah, so again, you see this x minus pi over 2, that's a cofunction. Look in your cofunctions and see how you can replace that. So that is the sine of x. If you look at your cofunctions, cosine of x minus pi over 2 is the same as sine x. So rewrite it without those big long x minus pi over 2's in there. Then you can factor it, I believe. So if I factor it, I got 2 sine x times sine x to get this guy. 1 times the negative 2 to get this guy. Outer would be negative 4, inner would be plus 1. That gives me a negative 3 in the middle. Set each one equal to 0, we get sine x equals negative a half, and sine x equals 2. However, sine x cannot equal 2 because it has to be between 1 and negative 1. So that answer is thrown out. Okay, be ready. Hopefully Friday will be a success for you. Bye.